So good day everyone. So before anything else, let us first discuss the continuation of the last reporter. So we have here let f from set x to set y be a function, and e and b is a subset of x. Then f of E union B is equals to f of A union f of B. So we have here the proof of f of E union B is a subset of f of E union f of B. So we have let x, the element of f of E union B, then there is an element of E union B such that f of E is equals to x. Then a element of E or element of B, fe element of E, then x is equals to f of E and element of A. So if element of B, then x is equals to f of B, an element of f of B, either is x an element of f of B union f of B. So another one, f of E union f of B is a subset of f of E union B. Let x element of f of E union f of B, then either is x an element of f of B or x an element of f of B. If x an element of f of E, there is an element of E such that x is equals to f of E. In this case, a element of E union B and x is equals to f of A, element of f of A union B. So fx element of f of B, so there is an element of B such that x is equals to f of A. So in this case, element of E union B and x is equals to f of E, an element of f of E union B. So now let's proceed to subjective function. So here's the definition. A function from set E to set B is said to be surjective or onto if for every element y in set B there is an element x in the set E, such that f of x is equal to y. So now let's have an example. Suppose we have in set E with the number 1, 2, 3, and 4. In set B, we have E, B, C, and D. We're going to define the function phi that maps 1 to A, 2 to C, 3 to B, and 4 to D. So the question is this surjective? So let's look at the definition for every element y in the set B. So the element in set B, which are E, B, C, and D, input, and it says also in definition that there is an element of x in the set E such that f of x is equal to y, or in our case, pi of x is equal to y. So makita nato that pi of 1 equals to A, pi of 2 equals to C, pi of 3 equals to B, and pi of 4 equals to D. Now, another example. Let's define the function chi that maps 1 to A, similar in our previous example. But in this example, there's nothing gets mapped in B. So, why ay nakamap sa B? So, in this case, ma-consider nato na or ma-conclude nato na this is not a surjective, because when we say surjective, dapat every element in set E nakamap sa every element ng set. Every element in set E dapat nakamap sa every element in set B. Just like an example nato previously, but in kay din himong good example, there is one element na wala siya nakamap sa other set or sa set E. That's why we can say that this is not a surjective. So now, How can we prove that the function f, or how can we prove that the function f from set A to set B is surjective? So we have two steps. So in step 1, let y be some element of B. In step 2, find an element x and as such that f of x is equals to y. And here's an example. Show that the function f from set of integers to set of 5 times the integers 5z given by f of n equals 5n is surjective. Okay, here's the proof. Let y be an element of 5z. Then y is equals to 5z for some integers n. But this means, before we proceed to another one, let us first solve this equation, the y is equals to 5z. We will divide it both sides. So y divided by 5 is equals to 5 and divided by 5. Then cancel the 5 over 5. So ang mapabili na lang is y over 5 is equals to a. Or na ato balik ato plus taron na mo siya in is equals to y over 5. So this means that in is equals to y over 5. So the next one is we will plug in the value of n. So f of n is equals to 5n. So Rn is equals to y over 5. So 5 times y over 5. I mean 5 times y over 5. Then cancel the 5. So ang magpapinuntakan is ang y. So we can say thus if f is a surjective. So the function of f from set E to set B is to be injective or 1 to 1 f for all x sub 1 and x sub 2 is an element of A. F of x sub 1 is equals to f of x sub 2 implies x sub 1 is equals to x sub 2. So we have here an example. So for example number one, we have in set E we have 1, 2, 3, and 4. In set B we have E, B, C, and D. So makita nato that every element in set E is nakamap sa every element of set B. So we can say that this is an injective function. So we have here another example. So parihara kain ha, parehara ng mga set, number and letter ng mga set. But in this example, there are one element na waya makamap and there are two element na nakamap siya sa isa ka set. So we can say that this is not an injective function. Now, how to prove that that the function of f from set E to set B is injective? So we have two steps, just like in surjective we have two steps. Here in injective we have also two steps. So let x sub 1 and x sub 2 an element of A, and suppose that f of x sub 1 is equal to f of x sub 2. Then the step 2, show that x sub 1 and x sub 2. Now, here's an example of injective function. Show that the function of f from real number to real number given by f of x is equals to e to the power of x is injective. So here's the proof. Let e to the power of x sub 1 and e is equals to e to the power of x sub 2, an element of real number, and suppose that f of x sub 1 and f of x sub 2. Then e is to the power of x sub 1 is equals to e to the power of x sub 2. So it's great, but this means that x sub 1 is equals to x sub 2. So we can conclude, we can say that this is an injective function. So now we have another one, the bijective function or the bijection. A function on f from set E to set B is bijective f and only f. It is an injective and surjective. So we can say that a function is bijective if it is injective and surjective. So a function from, so we can as a recap, di ba, ang definition ng surjective is a function of f of e from set E to set B is said to be surjective or onto if for every element y and b there is an element of x and e such that f of x is equals to c. So that's the definition of surjective as in our previous discussion. And the definition of, as a recap also, the definition of injective is the function of f from set A to set B is used to be injective or 1 to 1 f, and if for all x sub 1 and x sub 2 is an element of E, f of x sub 1 is equals to f of x sub 2 implies x sub 1 is equals to x sub 2. So that's the definition of surjective. So we have here an example for bijective. We have here an example of bijective f, the function of f from natural number to natural number, where f is equals to the set of E and B such that P is equals to A. So this function is objective. So how can we prove that this function is bijective? So, di ba kanina? So, di ba kanina is nilong kita. Now, we can prove that the function is bijective if this is an injective and surjective. So, first, we will prove that the f is injective first. So, suppose that f of E is equals to f of B, since f of E is equals to A, and f of B is equals to B, we have that E is equals to B. So, f is injective. So, that's it. So, after we prove that f is injective, we will now prove that f is surjective. To do this, consider that E, the element of E and natural number, the natural number, then f of E is equals to A, so E is in the image. Thus, the function is a bijective. Binary function. A binary function on set E is a function from A cross A back to the same set A. In other words, a binary operation takes two elements from some set and assign them to exactly one element of some set. So, for example, n times m is equals to n times n. So this example, this is a binary operation of multiplication. So when we say example binary operation of multiplication, it is a binary operation on the natural number for one multiplication is a function. So when we multiply two numbers, we will get exactly one answer. Additionally, if we multiply two natural numbers, we will always get another natural number. So that is an binary operation S. So another example, 2 times 4 is equals to 8. So in this example, we take natural numbers like 2 and 4. For example, we will get another natural numbers. Numbers exactly 1. In this case, we have 8 because our answer is 8. So this is an example of a binary operation.